Hello guys, welcome to MinuteScience YT channel. It's already 2 September 2021. So today we're gonna discuss about the Fermi paradox. Means, is there anyone out there? In its simplest terms, the Fermi paradox asks, given that the chances for life to arise seem abundant, why have we never detected it apart from our own planet? Asked another way, is there anyone out there? Scientists plug their best guesses into the Drake equation and most come to the conclusion, yes, it seems very likely that universe is abundant with life. If this is the case, then why we have not detected evidence of radio waves, space probes, industrial constituents in the atmosphere of the other planets, or even byproduct of plant life or bacteria, etc. In outline, the argument runs like this. The Milky Way contains hundreds of billions of stars, and billions of them are similar to the Sun. It is highly likely that some of these stars will have planets that are similar to Earth. If we assume via the Copernican principle the Earth is not particularly special, then intelligent life should also exist on some fraction of these Earth-like planets. Some of these intelligent life forms might develop advanced technology and even interstellar travel. Interstellar travel would take a long time, but as there are many sun-like stars that are billions of years older, there has been plenty of time for such travel to have occurred. Given all this, why haven't we met or seen any trace of aliens? Where is everybody? There are several good reasons as to why we have not yet detected life. Even if it is very abundant, here are just a few. The galaxy and the universe is vast. It covers far greater distances than we can grasp. Even if there are trillions of populated planets, it would amount to a tiny fraction of a star system. The chances are slim that we would have encountered or identified one of them yet, given our nascent stage of sky searching and space exploration. It is possible that intelligent species exist, but have not invented radio or radio telescopes. This removes our key means of detecting them. It is possible that intelligent species exist but have no desire to ponder their place in the universe or communicate with anyone far from home. It is possible that intelligent species have existed in the past, but their timeline did not overlap with our observation distance. That is, even after accounting for the distance and time involved, they may have extinguished themselves with pollution, war, global warming, as we are doing, or they may have been killed off by a celestial event such as large asteroid or solar discharge. It is possible that intelligent species exist and have already reached out of us, or we have already detected the evidence, but that we simply did not understand what we are observing. That is, we may not have any way to communicate with nor even recognize life that is very different than our own. They may use things other than speech, radio, sign language, etc. They may not even have eyes and ears. We are rare. For life to achieve intelligence and develop technology is very rare. Natural catastrophes or just ordinary predation can easily eliminate any branch of evolution that goes the big brain route. So it's entirely possible that there are millions of planets where the dinosaurs are the dominant species and the intelligent creatures can't overcome them. The Great Filter. This one is one of the most scariest and worth dwelling into. With no evidence of intelligent life other than ourselves, it appears that the process of starting with a star and ending with advanced explosive lasting life must be unlikely. This implies that at least one step in this process must be improbable. Hansen's list, while incomplete, describes the following 9 steps in an evolutionary path that results into the colonization of the observable universe. Star system includes organics and potentially habitable planets. The second one is reproductive molecules, example RNA, simple prokaryotic single cell life, complex eukaryotic single cell life, sexual reproduction, multi-cell life, tool using animals with negligence, civilization advancing towards the potential for a colonization explosion, where we are now. Colonization explosion. According to the Great Filter hypothesis, at least one of these steps, if the list were complete, must be improbable. If it is not an early step that is in our past, then the implication is that the improbable steps lies in our future, and our prospectus of reaching step 9 interstellar colonization are still bleak. If the past steps are likely, then many civilizations would have developed to the current level of the human species. However, none appear to have made it to step 9, or the Milky Way would be full of colonies. So perhaps step 9 is the unlikely one, and the only things that appears likely to keep us from step 9 are some sort of catastrophes. An underestimation of the impact of procrastination as technology increasing unburdens existence or resources exhaustion, leading to the impossibility of making the steps due to consumption of the available resources, for example high constant energy resources. So by this argument, finding multicellular life on Mars, provided it evolved independently, would be bad news, since it would imply steps 2 to 6 are easy, and hence only 1, 7, 8 or 9 or some unknown steps could be the big problem. Although steps 1 to 8 have occurred on Earth, any one of them may be unlikely if the first 7 steps are necessary preconditions to calculating the likelihood using the local environment. Then an anthropopically biased observer can infer nothing about the general probabilities from its predetermined surrounding. In a 2022 paper, Jacob Huck Misra, Ravi Kumar Kupparappu, and Edward Schmidt argued that current and future telescopes searching for biosignatures in the ultraviolet to near infrared wavelengths could place upper bounds of the fraction of planets in the galaxy that host life. Meanwhile, the evolution of telescopes that can detect technosignatures at mid-infrared wavelengths could provide insights into the great filter. They say that if planets with technosignatures are abundant, then we can increase our confidence that the great filter is in the past. On the other hand, if we find that the life is commonplace while technosignatures are absent, then this would increase the likelihood that the great filters lies in the future. Though the Fermi paradox is the accepted name for the argument, some argue that it more properly belongs to Hart. Whoever is responsible for it, there are many numbers of proposed answers to the question. The most obvious is that we are alone, Earth is unique or close to it in having life. Alternatively, large-scale interstellar travel may be impossible, or perhaps intelligent life will inevitably destroy itself via nuclear weapons or runaway artificial intelligence or global warming or something else. Other ideas include the suggestion that we are not looking for the right kinds of signs, or that aliens are so alien we cannot even recognize them as living things, or perhaps other civilization and deliberately keeping us in the dark until we are ready to join the galactic community. Or perhaps other life is abundant but living in subsurface oceans, such as that thought to be on Enceladus, unaware that anywhere or anything else exists. The possibilities are endless, and speculation will no doubt continue forever or until we find extraterrestrial. Fermi's lunchtime conversation petered out, according to Edward Taylor, another physicist who was present, with the conclusion that as far as our galaxy is concerned, we are living somewhere in the sticks, far removed from the metropolitan area of the Celtic center. So guys, thank you for watching.